Now, continuing on the previous video about Directlogics, this time I decided to implement PID control loop. And again, I have a thermocouple attached to the thermocouple input card. I'm only using one single thermocouple. And here, dangling from the little hook up here, I have a soldering iron. I don't have anything heater-wise, so this is my heater. I've connected the this box here has a solid state relay um, built in that I did a while ago. So that is connected to output 0 here on this solid state discrete output on the Directlogics. This here is Y100, and I'm running 24 volts coming from the PLC output of 24 volts and across a resistor here of 560 ohms. So I can drive a little SSR here. And on the DirectSoft program, sorry, I implemented, after several hours, a proportional integral control loop. I left out the differential, only did proportional and integral. Sorry. And I decided to convert values to floating point and do the math using floating point or real values. So I started using all these boxes or instructions from DirectSoft to convert from integer to real. So basically I have a gain here and a proportional gain, a integral gain, a cumulative error, and then there are some components that go into the control loop here. So let me just convert this. This is still not showing us decimal. There it is. So all this is taking the set point and current temperature on the thermocouple and obtaining the error here. Let me show it down here. So this is the conversion to temperature for the thermocouple up here. The accumulated error, the error is the difference between the set point, which is a non-volatile variable, minus the thermocouple in real format. So that's 0.04. Right now, the thermocouple is at 94.32, and the set point is 95. So there's a slight error here, about 1 Celsius. So all of that gets multiplied by the gain, and it becomes a proportional response. And if the error, if the value is negative, then there's a bit that I use, because this PLC has no compare for reals. So that's a challenge. How to exploit this is I had to use a special system bit. If the value is negative, I reset a Boolean internal relay C11, and then I have an integral time of 100 milliseconds. That's my integral time. So I'm constantly pulsing that and adding the error here. So the error gets, right now the error is minus 989, and it's becoming less and less because temperature is 93.5, set point is 95. So it should get closer to it as time progresses. 94 right there. And then I just add them together here into the this is where it gets added, both components, but they need to be converted back to sorry, integer values. So, and then multiply, sorry, by the value of the periodic. So I have a timer here that is about 10 seconds. So the duty cycle on the timer is what turns out that output. So if you see that neon light bulb, that is the output going on and off. So that there indicates when the output is turned on. So that's the duty cycle. So it's converting PID into duty cycle. And then I decided, because Modbus or Modbus TCP will not transfer floating points, I needed to get the floating point or real values. So I decided to use Kepware. And Kepware here, I have Kepware here. Let me just minimize this. Kepware here is running. And this device here is Automation Direct PLC on port 2, running the DirectNet protocol from Automation Direct. So that's what it's doing here. So I have all these variables that I see here on DirectSoft, right? The same variables that I have on here. This is the integral gain, proportional gain, set point, and temperature. And I have the quick client showing the values here. So I can change the set point at will, right? I can change that by writing synchronously to that tag. So let me just click set point here and synchronous write, and I can change the value, say, to 100 and see if I can get that to heat up. Yeah, maybe not, maybe 110. That's 110, and this is going to change as well. So watch it. Apply, and the set point change. So the proportional gain went up. The integral gain is becoming more positive, right? And as you can see, the light bulb stays on, and then it just goes off after it reaches the set point. Tries not to overshoot. Proportional still pulsing. The integral still negative, but it's gonna go. It's gonna progress. So I haven't tuned the system, right? And you can see here on Kepware Quick Client, the temperature overshoot to 115 Celsius. So there's some overshoot. So it should normalize briefly. Of course, this is a very closed system. All I have is a soldering iron and a thermocouple attached right to it. So there's a very quick response on the system. If I were to move this thermocouple away, you probably have a different response. So when you tune a system, if you change something in your machine or equipment, you need to, if you move your thermocouple or device to a different location, or even changing the thermocouple or its wires or whatever, you probably need to go back and retune the system because the physical system changed. So that's what I have not done yet here. The system is not tuned, but I have controls of the gains, and I'm using Kepware to do that outside of DirectSoft. So here's a system running a PI control loop and using Kepware. Thank you for watching.